Hello, and welcome to our VAST customer training webinar. So our webinar today is going to be on VAST replication and data protection. So while you're getting settled, give you a few tips as we move forward. So my name is Kristen Thompson. I'm the Director of Customer Education here at VAST. So welcome. I want to make sure you all are aware we have a customer learning portal as well that includes on-demand content available for you at any time. The recording for this webinar will be sent afterwards as an email and also will be posted inside our customer learning portal. So during this event, you have the chat window available, and we would love for you to post any questions that come up, and we will have a team on to help answer those, or they can be answered live at the end if needed. So that is my little preamble there. Thank you for being here. And I'm going to invite on stage our wonderful presenter, Phil Wagstrom from the Office of the CTO, who is going to be sharing with you all of the information for today. So with that, I'll turn it over to you, Phil.
All right, thanks, Kristen. Morning, everyone. So as Kristen said, we're going to be talking about VAST replication or native replication within VAST. Just to clarify, kind of set some ground rules, some limits as to what we're going to be talking about here. This is going to be, I'm going to be going through strictly just the asynchronous replication, things we call data protection within the VAST GUI. So this is going to be your async replication between two different VAST clusters, or it's going to be things related to snapshot and data protection. Some other later webinars will go through some of the other options, things like global namespace or synchronous replication, S3 replication, things like that. But today we're going to focus just on native replication, native asynchronous replication between VAST clusters and snapshotting and all of the wonderful things around that. So with that, let me go through. I'm going to share out my screen and we will get started here. So let me share out my screen and let's get going. All right. So with that, let's begin here. Pardon me while I get things going. So we're going to be talking about a few different topics today. As I mentioned, we're going to be talking about the VAST native replication. We're going to talk about VAST protection policies. We're going to go a little bit about indestructibility or immutable snapshots that we have. From there, we're going to go into a protected path and how that all operates. We'll talk a bit about failover, so how we would go through and failover replication from one cluster to another. We'll talk about the group cluster failover, the group failover capabilities that we have. We'll talk about how we do recovery of data, not only from a rolling back of an entire snapshot, but also if we're talking about doing some granular recovery, like how do I get back a file that was deleted or a directory that was deleted, what the options are around that. And then lastly, we're going to cover very briefly cloning. So that would basically, how do we go through and how do we take a snapshot and create a clone of a file system, or generally just take a clone of a file system, clone of a view completely, and create a new view or a new copy of that data very easily. So let's get started with VAST native replication. So when we talk about VAST native replication, we've got various different options for this, and these are not unique to VAST. For it. So we do support, one-to-one replication where we can take a directory or we can take a view and replicate that data over to another VAST cluster. We also support doing a one-to-many type replication. This one-to-many could be, I want to go through and I want to replicate a single view or a single path to multiple VAST clusters. I could take different paths and replicate them to multiple VAST clusters, any one of those there. When we're talking about our asynchronous replication, we do support up to a 15-second RPO, and an RPO being a recovery point objective for this, which means we can go through and take snapshots about once every 15 seconds for that. We can do things a little bit faster than that if need be, but generally that's about as fast as we go, because it does take time to go through and do replication, and how much data we can replicate is going to be dependent upon several different things. Number one, it's going to be ultimately dependent upon what is the speed of the links between the two VAST clusters. You've got, it's only so big of a pipe that you can transfer data. If the amount of data you need to replicate exceeds that pipe, well, that's going to take time there. So there's some limiting things there. As we also go through when we're going through and we're doing our replication for this, the replication is going to be sent as a compressed delta between the systems. So if we look at the replication that gets done, let's say we have a file, a one terabyte file that we want to take a snapshot and it's going to replicate out, or multiple files for that matter. But we're going to go through that initial replication, obviously has to replicate all of the data. Well, let's say we make a change to that 1 terabyte file. Let's say we make 100 megabytes worth of change to that file, either by extending that file to make it a little bit larger or changing existing data within that file. When we go through and we replicate again, the cluster is aware that, hey, only that when the replication happened last time, we had the file like this. When we were replicating this time, this file is changed by that amount. We only have to replicate the deltas or the changes that were done between the file. There is, timestamps associated with the data, so we're able to recognize that, hey, we don't have to replicate the entire file. We can just replicate that delta. Those deltas are going to be compressed for the replication. So we will go through and compress those on the wire. However, these deltas will not be deduplicated. And really, the reason we don't do any deduplication on those is that the deduplication tables between the different clusters are going to be completely different for that. So it doesn't make sense to try to dedupe those. When we're talking about the replication does have the option. By default, when we set up, you do have the option to go through and say, hey, I want to send this unencrypted for that. But we do have the option to go through and do encryption of that via mTLS. And what mTLS allows us to do is that you basically set two different certificates. Both clusters will have to be able to validate that those certificates are valid, and so they know who exactly they're talking to. So you do have an option to set up mTLS. The replication is going to be snapshot based for this, and you will see .snapshots full files and folders, the snapshots on both sides of the cluster. So with this here, as I said, we can do one-to-one, one-to-many for this. We can also go through and we can do many to one. So this does not necessarily mean that you're going to have 4 different clusters replicating the same view to the same location on the target cluster. That wouldn't work. Obviously, they'd be overwriting each other, but we more than happily support multiple clusters replicating data to different unique locations on one cluster. Same things there with encryption and behavior there, 15-second RPO. Again, obviously subject to the amount of bandwidth that you have between the clusters, the delta of the data that you have. Now, we also here, when we're talking about replication with one-to-many, we also support multi-site replication. So in this example here, we can replicate from a primary site to multiple secondary sites. And in the cases of a failover, we can still maintain that relationship between the primary and secondary sites. They are aware of each other. There is synchronization that goes on between all of them, such that when we do have to fail over between sites, we don't have to reestablish replication rules between the secondary sites. They still replicate between each other. So in the case here, we've got 3 different locations. We've got London up here on the left. We've got New York on the right. We've got Sydney as well. And these sites are going to be replicating between each other. London is going to be our source site, and that's going to have a replication job that's replicating to New York as one target. It's also going to replicate to Sydney. Now, this replication could have the same replication schedule if we wanted to, but it doesn't have to. Maybe we are, using Sydney as a tertiary DR site, and rather than replicating it as frequently as we do New York, maybe instead of replicating once a day, we just send once a week replication over to the other site, or once a night, something like that. But it could be the same schedule. It could be a different schedule. Now, however, in order to go through and make sure that we have some replication that lines up between the source and the target, there is going to be a configurable checkpoint that will get generated between all the sites. So we basically will have a common source of reference between the three different sites, a common snapshot that we can go through and utilize. And that common checkpoint can be set at whatever schedule that you want for that. So completely configurable. So in this case here, we're replicating both. We're replicating from London over to New York and from London over to Sydney. And this is normal operation. We've got some replications that are going on. Well, let's say if we have London fails for some reason. for that. Maybe there's a power outage in that data center. Maybe there's some other problem there. Who knows? But London fails down. And we want to go through. We want to bring things live on New York. So what we'll do is that we'll go through, we'll bring sites live, we'll bring things live on New York, and what will happen is that there is going to be initially with just New York and Sydney, is that there is going to be a partial resync that has to occur between New York and Sydney. So this partial resync is going to be based on whatever the last common checkpoint was for this, and once that partial resync occurs, New York and Sydney will resume. Will have their replication that will resume according to that same schedule that was coming from London. So, but again, we don't have to do a complete resync between that. Even if New York and Sydney are not using the same schedules, don't have the same snapshots, they do have that common checkpoint. So that resync is only going to be whatever the delta is between that common checkpoint that happened. And then from there, the replication will continue according to whatever the schedule was that London was replicating to Sydney. New York will continue that replication to Sydney according to that particular schedule. So when we have, when we come back, when that node, the original source node comes live again, we are aware that it's times have changed. We'll go through and we will look at the last common checkpoint that we had when the replication happened, and we will do a partial resync between New York and London, in order to resume that replication, and then we will continue upon that schedule to reverse that replication from New York back to London for that. Now, when we go through and we do this reverse replication, or when we bring London back online for this, this is completely controllable. We'll talk about this as when we go through and we talk about failovers, because we don't want to have the replication start up immediately upon the original source coming back, and possibly overwriting some delta of data that you wanted to actually recover before. So we realize that there may be some changes there that happened on London that didn't make it to New York that you want to preserve. So we'll bring that site back. You can bring that site back up, and then choose when you want to go through and resume that replication. And when you resume that replication, obviously it's going to bring London in line with that other source. Okay, so that's one option. Now, the replication that we do for VAST is going to be using a native VAST protocol, but we also do have another option here to replicate not only between different VAST clusters, but we have an option called Snap to S3, which allows us to go through and do a replication to an external S3 bucket. So rather than doing VAST to VAST replication with the snapshots, we can take that snapshot, that snapshot image, or basically that delta, use it as a single object, and then replicate that or send that up to some S3 bucket. It doesn't have to be a VAST S3 bucket. It could be an Amazon S3 bucket somewhere, some other S3 bucket out there. But it's another option to go through and be able to replicate out to different locations that are non-VAST related. This here, unfortunately, is going to be as flexible as VAST to VAST replication. And when I say not as flexible, it's that you don't have the ability to go through and access individual files on that S3 target or from there. It is the objects that are uploaded are going to be that delta, that delta object that contains all of the deltas from all the files between one snapshot and another. So it's really more like a last, a cold backup type option, much like you do with tape backups from there, where you have your initial full sync, and then you've got your dailies and your weeklies and things like that. This is similar to how that would work, but it's another option to go through and make use of there. So let's talk about how we go through. Let's go a little bit more into how we go through and we set things up within the VAST clusters to define what the rules are. So when we're talking about replication, if we just like we have view policies and views, we have protection policies and protected paths. So a protected policy is going to can have a couple different things. Now, first off, a protection policy can not only encompass replication jobs, but it can also encompass just snapshots. But if we're talking about replications, we need to go through, we need to set something up first. So first off, when we configure things, we need to set up a peer relationship between the two VAS clusters. We only have to set this up from one cluster. Once we initiate that from one cluster, the peer relationship is established on both for this. So when we go through and we set this up, we'll go into the VAS GUI, we'll go under data protection, and we'll say, hey, add a replication peer. And when we do that, we'll get this screen here that will talk about, hey, we need to establish a peer name for this. And this isn't really going to be the name of the other cluster. It's going to be, what is this relationship called for this? So typically I would go through and put, hey, this is, New York to Sydney, for this, or New York to London is the relationship for it. We'll go through and we need to specify what the remote VIP is of that pool. Now, this is going to be when we go through, when we talk about, if you were here for the networking discussion, the networking webinars, when we go through and we create our VIP pools will have different possibility of different roles. Typically, this is going to be a protocol role or it's going to be a replication role. So with this here, we're going to specify an IP address for a VIP pool that has the replication role. We don't have to specify specifically the management address of the remote cluster we're connected to. We just need to have a VIP address. And consequently, we don't necessarily need to have from the source cluster to the destination cluster, that does not need to have access to the management network between the two of those. This can be done just strictly over the replication network for this. So you have some dark fiber, you would set up a link there to go through and do that. So we specify just a single remote VIP address that is that is part of a VIP pool. It's a replication pool, and the clusters will go through and communicate and determine all of the additional VIP addresses there that are available within that replication pool. Locally, we need to specify which local VIP pool we want to use for this. Again, this is going to be your replication VIP pool that you defined. Today, as of 5.3, we still only support a single VIP pool for replication. That may change in the future, so that's why it's a drop-down menu. But right now, we would only just have one option in there. And then from there, we can select the security mode that we want to use. And the security mode are basically going to be either none, meaning we're not going to encrypt that replication traffic, or secure, which means we are. And that's going to be an mTLS encryption between two different clusters. Once that's done, then we can create a protection policy. So a protection policy is going to have, a few different things that we need to find. So first off is we need to give it a policy name. This is going to be a human readable name. Like, I want to create something, say, production 1 hour or production 1 hour retained for 1 day or this, or, source code backup or something like that. You'll create it as you just, give it a name that you define. You'll also go through and provide a snapshot prefix. And the snapshot prefix is going to be for any snapshot that is created from these protection policies. What do we want to go through and call those snapshots? What do we want the prefix on those snapshots when they get created? And then from there, we'll go through, we'll set down here the schedule that we want to go through and create those snapshots on. Now, the schedule here is not necessarily going to be number based in terms of I want to have 5 snapshots or 10 snapshots or how many I want to retain. We're going to specify based on the periods that we want to go through and create the snapshots and then the amount of time we want to go through and create the snapshots. So you can go through. So this allows you to not have to think about, oh, yeah, I want to keep 10 snapshots or 20 snapshots. I just say, hey, I want to keep snapshots for 1 day. Now, I'll make a caution here that with these here, you can generate a lot of snapshots somewhat unintentionally. If you set your snapshots for, every 5 minutes and you go through and you keep those for 30 days, that winds up being a lot of snapshots because you're taking snapshots every 5 minutes. You're keeping all of them for 30 days. So you have 30 days worth of 5 increment snapshots that you're keeping around. So just be aware of that. If you start having a lot of snapshots there, you will get a warning saying, hey, this is going to create this amount and so on and so forth. So we can go through, we can specify those there. We specify how often we want to take the snapshot, how long we want to retain those local copies for. Now, we also have the start at. So if I want to delay when I actually want to have this run, it will not start until that period of time when you specify to go through a run. So if you set up the policy now, you can say, nope, I don't want it to actually start replicating until midnight tonight or midnight tomorrow, and then it'll keep that schedule going from there. Now, If we are doing a local protection policy, I mean, I just want to have this do snapshots, that's all that I have to do. However, if I want to make this a replication policy to replicate out to other vast clusters, then I just need to go through and provide the peer relationship. So I'll click on the drop down, I'll see the peer relationship, I'll add that. As soon as I have that pop up, then I will get this keep remote copy for here, where it basically says, much in the same way, hey, I want to keep remote copies of these snapshots for this amount of time. There can be different retention periods for both the source and the destination. Now, I can add in additional schedules in there into the same policy. So if I want to have, let's say, hourly snapshots and then a daily snapshot and a weekly snapshot with different rules on each one of those, we can all put those underneath the same policy. And that's allows us a lot of flexibility to go through and do that. Now, the one thing that I have on here is we have this indestructible snapshot. So, what an indestructible snapshot is that this is a additional protection for ransomware. An indestructible snapshot, if you think about how ransomware attacks might happen, if the ransomware is familiar with the platform that it's on, or you've got a compromised system or something, typically what would happen is the first thing a malicious agent would want to go through and do is attack the backups, attack the snapshots, and delete those before it goes through and attacks the actual data. So you destroy the backup first, then you have to go pay the malware for that. Within VAST, we have these things called an indestructible snapshot. And what an indestructible snapshot does is that the snapshots are not only are the snapshots immutable, meaning we can't change the data that's in the snapshots anyways, but they also set up a schedule such that we don't allow changes of the policies or the deletion of any of those snapshots outside of those defined retention policies. So an administrator, a malicious agent can't go through and manually delete those snapshots or change the policies to say, hey, rather than keeping those snapshots for a week or a month, oh no, you're just going to keep them out for an hour, and then it prevents those changes there. So it gives you those kinds of protections to prevent that from happening. Now, in the case that you have to go through and you want to go through and make changes to those policies, like you to say, hey, I'm keeping too many snapshots, I'm using too much space, I want to shrink my retention ratios there, you do have the ability to go through and unlock the system to do that. But this unlock process that you do is going to be something that you would work with VAST support to be able to do. And when you turn on immutability, you work with VAST customer success with our support engineers to define what the policies are you want to be able to do that. And this is going to be, basically something like a two-factor authentication. You can define the people that on your side, the administrators on your side, how many administrators need to sign off on this for this, how they would identify themselves for this. To the VAST engineers, there's going to be multiple VAST engineers that would have to go through and confirm that, yes, you are who you say you are. We are talking to more than one person for this. And this is signed off on both sides. And these rules that you have are defined by you as the customer for this. Along with that, there is going to be a password that needs to be provided for the VAST cluster, one that you would define prior, to go through and say, hey, yep, okay, this is the system password. You would go through, provide that password into the cluster. That generates a hash for it. You provide the hash to VAST support as part of this authentication process that you've defined. VAST will reply back a challenge token or a response token. You plug that token in, and it unlocks the cluster for a period of 1 hour. That 1 hour is not configurable. It's going to be unlocked for 1 hour and 1 hour only. That would allow you to go through and make those changes you want to your policies, delete the snapshots that you need to. If after that hour you need more time to go through and do it, you can just talk to VAST support again, go through the same process, get another token, unlock it again for another hour to make those changes. But usually an hour is enough just to make changes to policies and things like that. So, but this gives you another option for this to go through and set this up. So once we have this policy set up, then we're going to be talking about protected paths. We actually want to set up and do this data protection, do this replication. So when we add a protected path, we're talking about this, in the sense that like quotas, like other things, this is going to be a path within the element store. So this path does not have to be necessarily aligning with a view. So I don't have to go through and have a protected path for every single view that I create. This protected path could be a subdirectory within a particular view. It could be a parent directory for this. So you could go through and let's take the situation where you may have different protection policies that you want to use for it. You may have a gold protection policy and a silver protection policy and a bronze protection policy with different different schedules and retention things like that. You could, depending on how you structure your views, you could have that gold policy back up from a path that starts with /gold, and you create any views that you want under that /gold one, and it will gather all the data in those views and replicate that as a single protection job. Additionally, for this, when we go through, we have a protected path. All the protected paths that are utilizing the same protection policy are going to be part of the same consistency group. So even if you have different paths, different protected paths there, for that, if they're using the same protection policy, they're going to be part of the same consistency group. Meaning, when we take the snapshots for everything that's on there, they are done at the exact same time frame across all of them. The data will be identical across all of those there. So that's another thing we can do there. By another reason we go through and have these protected paths, we use the same protection policy. So when we create a protected path, the paths are going to be done, from that we specify where we want to do it. If we're doing this as a cluster administrator for this, we would go through, we get a list here, would specify the tenant that we have. Now, if we're doing this, if you're running multi-tenancy, you're doing this as a tenant admin, you can still do these protected paths. You can still set up these schedules. You just would only be able to do this within the context of your own tenant. But as a cluster administrator, we select which tenant this path is going to be. We'll give it a reference name for this protected path for it. It doesn't have to be the path name. It can be can be whatever you want for, get a human readable name. But then we specify the local path that we want to replicate. Again, this would be where we put like /gold or /user1 or something like that from it. And then once that's done, we will set the protection policy. This will tell us what the peer is already. If we're replicating between tenants, we can select which tenant we want to replicate to for this. And then we specify where we want this data replicated to. It doesn't have to match the same path. The source and destination don't have to match the same path. They could be a different path. You could say, hey, you have the cluster name in the remote path if you're doing a many to one type replication, but you can specify those there. Now, once that's done, you'll go through and hit create, and it will go through and start the replication process there. Now, in the case where we're doing multi-site replication there, we would first create the protected path with one location on there, and then we would add another peer with the other schedule with a different protection policy for the other locations after the fact. So we can add those in afterwards. But initially, single path goes from there. Once the protected paths are established for that, we can take a look at the state of things. And we can see from here within the GUI, we'll see, what is the name of the protected path, what is the source path here, what is the destination path here, the source path, the destination path, what peer we are replicated to, the schedule that we're using, what the role of this is. So am I looking at this from the source, or am I looking at this from the destination? If I was looking at this at the target system, I would see, hey, this is going to be a destination role for this rather than the source role. Now, the one thing about protected paths that I'm going to iterate here is that this today only includes data and permissions in terms of the replication. The views, view policies, quotas, VIP pools, those are not replicated as part of the replication jobs. The only thing that is not data related that is replicated between the two clusters, or is not permissions or actual data related that's replicated between the two clusters, will be S3 keys. So with users, you have the concept, you have two local S3 keys. You would also have two remote S3 keys from the other cluster, because you may be using that for the other thing. We need to replicate those keys over to the other side as well to make those usable there. But outside of that, only the data and the permissions are replicated. Why do we do this? Well, number one, for things like the view policies, the networking may be different between the two sites, different subnets, different VLANs, different things there. Replicating the view policies doesn't make any sense from there. So those are not replicated. There are options where there are requests to go through and be able to do that for that. Those have not been implemented yet. Uh, so but that is something that will be coming at some point here. It's just not available today. So when we're looking at replication that's set up, and we have replication that is running, we can go through and we can look at what the state of that replication job is when it's running, and get an idea as to how fast it's going. What is the backlog for data? Now, admittedly, these slides here are probably relatively uninteresting with this, but when we go through and you right click on the protected path, you can select this analytics view. It will pop up the analytics, and it will give you things like, hey, what is the backlog for data? Meaning, if I'm going through and I've got changes that have been done on this, what is the backlog of data? You'll typically see this look kind of like a sawtooth pattern, because the backlog means there's been changes on the file system when the snapshot is taken that need to be replicated out. So we start up behind, and then as we go through and we start that replication, that backlog will go down, so it becomes zero at some point. And we kind of see that here, where suddenly we have a spike, but it rapidly goes down with this replication. So probably wasn't a lot going on here. And then we can see, how much bandwidth is being utilized by the replication job that's there, as well as, how much data has been transferred in the logical size of this particular protected path for that. So all this can be gathered from the analytics within the cluster itself. Pretty straightforward, pretty powerful. Okay, so let's talk about how do we accomplish a failover. So again, as I said, the data that is replicated across there is just the data that's replicated on there. It is something that's going to be visible. You can read it, you can access it there. You can also go through and create all your views and view policies there. It'll also be available on the destination side. Even when replication is running, it'll just be available in a read-only state for there. So you can do some validation as long as it's a read-only that you're trying to do. But let's say we want to go through and we want to do a failover. We want to do a site failover test, or we actually have a production outage and we need to go through and fail over to the other side. So how do we accomplish that? Well, protected path failovers, again, we can go through, we would go to the destination system first. We find the protected path that we want to go through and fail over. Right click on it, we say modify replication state. Well, first off, why do we go to the destination rather than the source? Well, the main reason is that when we're doing a failover, there's a reason why we're doing a failover. The source may not be available, so we're going to always trigger these from the destination side for this. The failovers that are done, they're done on a per path basis for this. There's not today there's not an option to say fail everything over, because you may be replicating to all sorts of different places, different clusters there. So we do it on a path by path failover. So when we go through and we want to we do this, we right click on the path, we say modify replication state. We'll get presented with this window here, and this window is going to pop up. It's going to give us it's going to give us some options here. If we want to do a graceful failover, meaning I want to guarantee that any data that's on the source right now today has been replicated to the destination before I do the failover, then that would be a graceful failover, as compared to an ungraceful failover, where it says a cut over now. Don't worry if the last replication hasn't happened, just cut over now. So in order to do a graceful failover, we're going to go through and we want to, when we get this window here, it's asking us here, how do we want to make this destination system that you're looking at, set up? Do we want to make this the source system, where we'll do one last sync across, and then we'll make it the source, and then we'll start syncing back to the other side? Or do we want to make it a standalone one? So if it's a graceful, we want to select source as the option. So it tells us here that this is the current state. We are writing from, this case here, var 203 over to var 202. This is the current flow. And if I select source here, it's telling us, okay, I'm going to make var 202 writable, and it is going to be syncing back to var 203. And var 203 is going to go into a read state rather than being in a write state. The amount of, when we go through and do this, there is going to be some time where we have to go through and initiate another replication to go through and sync that data across between the two of those. That does take some time. While that sync is going on, it does go through and put both clusters into a read-only state while that sync happens. It does give you some estimates as to how long it thinks that this will take. These estimates, I found, have been wildly conservative, meaning they give you scary numbers like, oh, it's going to take 40 minutes to go through and do this failover for something that there doesn't have a lot of time there. This takes worst case and factors in, a whole bunch of other extra things there. So it doesn't, very rarely would it ever take that amount of time to go through and do. So take that with a grain of salt. But you select that as the source. You click failover, it will go through and make the destination read write for that path. You can then go through and have your clients mounted on the destination. If you already have views established on the destination side already, you don't have to do anything. The clients can already have them mounted in a read-only state. Once the failover happens, they'll be read-write in the element store, and the clients can just start writing to them, no problems. So that's perfectly fine. If I want to do a standalone failover, so let's, again, I want to do a hard failover here, or the case where the source is gone completely for this. I need to bring the destination up. I need to bring it up right now. Or, again, I'm doing disaster recovery testing for this, and I'm just going to bring it up right now, whatever state it is. We would go through, we put the destination system into a standalone state. And again, this example here tells us this will be the state of things. Both 203 and 202 are going to be writable, but we will sever the link for replication. Replication will stop between those two while we're in standalone mode here. So we can do that. We say standalone, we click failover now. The destination becomes read-write immediately. On that, there's no additional resync that gets done. There's no, the synchronization or the replication that is done between the two clusters stops completely for that. And both sides are writable. Obviously, you now have two different data sets there that are going to be running independent of each other and are not replicating between each other for that. So let's say once that's done, how do I recover after that's been done? So if I want to recover, let's say I now have my destination that's been brought back up, or I want to go through and I've done my DR testing on my destination, I want to resume replication from the original source back over. Well, the way we go through and do this is that we go on the system that we wish to make the source system. Basically, we go to the system then that we want to make the source of truth or the final source of truth. If we were just doing some DR testing, this would be the original source because the original source is continuing to run production. In the disaster scenario, if we don't want to recover the data or gather data off of the original source system, and we just want to overwrite it with what was done on the failover system, then we go over the failover system to start this. So when we do this, we'll go through, we will go to the system we want to make the source of truth there. We will right click on it. We will say, hey, I want to become the source here. And it does confirm saying this is what is going to happen. Right now, we have two systems. They're unwritable. We're not syncing. We are going to go through. We're going to make this 203 system the writable copy. It is going to start syncing and overwrite and put the 202 system into a read-only state. And then any updates that have been made on the destination system here, so in this case here, any updates that have been made on that destination system will be discarded and thrown away for that. So it does give you the warning saying, hey, I am going to throw away any changes that have been made there for this. And once that is done, it will roll those changes back, and then replication will resume at the next interval. It doesn't start to sync right away. It waits until whatever the next replication interval is. If you do want to go through and you want to kick it off right away, you can go into the protection policy and say, hey, nope, I want to, where it says the start time, you make the start time now. And kick it off that way, and it will start the replication back immediately upon that. So we can do that, the recoveries, that we can restore that way. Now, if we're looking at doing snapshot restores, like let's say we want to go through and I want to do a rollback of an entire protected path. VAST does things a little bit different. We actually will go through, and when we do a rollback of a snapshot, we don't actually do a rollback. We utilize what we refer to as a global snapshot clone. I'll get into more details about that in a little bit. But we basically create a copy of, or a read-write copy of the snapshot that you use and rename the old one. So in the case here, we'll go through, you will click on the snapshot you wish to restore, or click the path you wish to restore, select the snapshot that you want. From there, it does temporarily rename the snapshot there, or the existing data with a new name for that. You can go through and say, I want to commit that change. Then it goes through and renames it to a slightly different name for that. And then per any replications that might be, or any protected paths, any snapshotting continues with the restored, based on the stored data there for that. So that's if we're not doing a replication. If we're doing things from replicated data, it does the same method there. Really, the difference is here is that when it comes to doing replication, because of how we have snapshots and set up from there, when we go through and we restore an entire snapshot from there, it does not reestablish the replication that is there. We need to create a new protected path based on the new path. It moves the existing protected path to a new name. It will continue that replication based on that old path, based on that path name. We have to establish a new path to do replication, or a new protected path to continue replication based on that new data. If we're talking about wanting to do granular restores are much simpler. They can actually be user driven. So within VAST, there is going to be a directory called .snapshot that exists. This .snapshot directory, there are two different options to have it. It will exist at the top of the protected path. Within the view policy, when you set up the view policy, there is an option under advanced, which is set by default, to say make snapshots available in subdirectories. And what that basically means is that any subdirectory that I'm in, regardless of where the protected path starts and is taking its snapshots from, I can CD down into that directory, see the snapshots that are listed, and access data relative to the path that I'm in currently. So the .snapshot directory is going to be hidden. This means not only is it hidden because it's a .snapshot directory, it's hidden from an ls-a. Main reason for that is you don't want to have something go through and do a complete directory listing or a full directory listing and start trolling down into snapshots and getting hung up there because you've got lots of snapshots there reading the same data. So it's going to be hidden from an ls-a option there, but you can CD down into it from there. When you CD down to that directory, you're going to see all of the snapshots that cover this path from there. If you CD down into one of those snapshots that are listed in there, you will see the file system in a read-only state at that same time that snapshot was taken. You can then go through and copy that data back to your live file system, retrieve that file, retrieve that directory back to the live file system from there. This is also something that is available if you're doing S3. So with S3, what you would need to go through and do is that from the S3 bucket, you would need to go through and just specify .snapshot as part of the object name, and you can go down and retrieve it from there as a snapshot. Now, this is going to be different than things like having versioning on an S3 bucket. This is strictly with just the snapshot functionality that VAST has. Normally, you'd use this kind of functionality as opposed to previous versions and versioning with buckets. You use this if you're doing multi-protocol with like an NFS flavor or something similar to that. But you can access those snapshots there. Now, if you're doing things from Windows, we can make use of previous versions. So with Windows, this can be a native SMB functionality for that. And this again allows users to restore accidentally deleted files, allows them to easily browse those files. It's part of Windows. It's part of the SMB protocol for that. When you're going through and you're looking at a directory that's out there, you will see all of the snapshots that are available, for that there. If I want to go through and I want to restore, let's say, a file or a directory, I just have to go through, right-click on the directory, right-click on the file, find previous versions for that, and I can either click open or I can click restore, and it will give you the option either to open that file or directory in another browser window, or restore that to a location that you choose, whether that be the live file system, whether it be your desktop, however you wish to go through and do that. Now, the one thing I will point out here is that these, with the previous versions that you have listed on here, these are not going to line up directly with the snapshots. It is going to show the version based on the timestamp that that particular file or that object was changed. And even if there have been, let's say you're taking snapshots on a 5-minute increment, if the file that you're currently looking at hasn't changed in any one of those snapshots, you won't see any previous versions, because there haven't been any previous versions the snapshots have captured for that. So don't be surprised if you go through and look at something and say, hey, I don't see any previous versions for this file. I know it's been captured by snapshots. The reason is you haven't changed the file at all. If you make changes to the file and then look at it again, then you will see the previous versions that are in those snapshots. So finally here, we have global snapshot clone. So if we want to, let's say, take those snapshots and make a read-write copy of those snapshots, we've got some flexibility here for this. We can use those read-write snapshots either locally, but we can also go through and do things like create a copy on another vast cluster. Now, this copy, we just have to have a peer relationship established with the vast cluster. The snapshot that we're trying to make a clone to does not have to exist on the destination system. So we can basically project a snapshot over there, very similar to the way that our global namespace works, but it's a little different functionality because it is read-write, and writes happen on wherever that clone winds up being for them. But it gives us these options here. So when we go through and we do this, we can go down, find our snapshot, right click on it, say I want to make a global snapshot clone, or go into data protection, global snapshot clone, say create a new one. We get a list of a snapshot, and we get these kind of window. We get a window that pops up here that tells us what we want to do. We give this clone a name, again, just a human readable name. We select the source cluster, the source tenant, the target path that we want to go through and use for this, so we can control where we want to have these set up from. For this, if I'm doing this where I want to present create a global snapshot clone on a snapshot that's not local, that doesn't exist on the cluster that I'm working from, I would need to initiate that from the cluster that I want it to show up on. Because if you notice here, it doesn't say destination cluster, destination here. It says source cluster. So we would go to the destination we want to have it show up on. We could say, go to this, look at the source cluster, find the snapshot, find the tenant that I want, and then create a clone based on that. So we select that, we select where we want to have it go through and create that clone to in terms of the path for this, and we can go from there. Now, what will happen is that we have this option here called background sync. And what background sync does is that initially, if I have this turned off, all that will show up on the destination side, the only data that has to be replicated out to the destination side or copied out there for this clone, is just going to be the metadata. As we start reading data from there or trying to access data there, that data will be replicated or copied for that, and then it'll be used there. But we don't have to go through and copy the entirety. Maybe we only want to get a small portion of that over there, or we want to work just temporarily on a small data set. So we can make use of it that way. But this is going to be an independent copy of that. We can read and write to it. All the reads and writes will happen locally to the cluster that we're on. Now, if I want to make this a complete copy of things on this, and I want to proactively hydrate everything out there, then I can toggle this background sync. And this background sync will go through and start copying data out or replicate data out. So there's going to be a complete independent copy, whether it be locally or remote. Now, because the clones are going to be read-write, we're not going to, that data, even though we're making copies of it, even locally, it is going to go through and be deduplicated and so on and so forth. So it does make a copy, but the amount of space in the end that gets used is going to be minimal because it will immediately be reduced, like obviously with compression and things like that, but it'll be reduced because it's going to be an identical copy. It'll be deduplicated based on that. So once that has happened, or we have a completely hydrated copy of this clone there, we can actually go through and delete the dependency upon the snapshot and have a live independent copy of that with no dependencies upon any snapshots. So a very powerful tool either locally or to go through and do things remotely. We can take these global snapshot clones either from data that is just based on snapshots locally or data that has been replicated out, and then we're working with a snapshot that is part of a replication for it. So very, 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 very flexible. So with that kind of goes through. That's kind of the conclusion of the slides here. So I'm going to just kind of touch on a few topics here very, very quickly, specifically again to kind of emphasize how the snapshotting works here in the timer, how we see those snapshots there. So in this case here, I have a NFS mount that I have established on this cluster. I have let's get my window open up here. So I have on this a protection policy established. So I go through, take a look at my protected paths here. I'm going to see for this that I have let me find my path here, my state, my path, local path. Look for this here. So I have a path here with just some snapshots associated with that on these two ones for NFS and SMB. These are both covered by a protection policy that I've defined for this that has, I'm just doing a 5-minute increment. I'm keeping these for 1 hour on this. I can add additional snapshots if I want to for this, but this is going to be a local one. These are not destructible. So I have a whole bunch of snapshots available to me for this. I can search for this based on the name of the path that is being recovered. So I see all of these snapshots here that have been generated from this. So if I go through and I want to look at my clients here, I've got my Windows client, my Unix client here. I have a directory here. I've got a file here called test file. There is some data there. I'm going to go through and just update this file here for this. And we have this file there. It's been updated a few times throughout the day. But let's say, oh, gee, I overwrote it. I want to go through and I want to get it back. Or let's say, we'll just do this. I'm just going to go through and just remove this file. And I want to get this file back. So I don't have my live directory, but I can go through and I can do into a cd.snapshot directory. And what I'm going to see there is I see, hey, here's all the different snapshots that we had for this file. So I can go down into one of these snapshots. Let's say, okay, I knew this file was there, 5 minutes ago. So I'm going to go into this directory here from, let's see, we'll go about 5 minutes ago here. Yeah, that's right. Yeah, we'll use that one as an example. There, we're going to go into this directory here, and I'm going to see, oh, there's my test file. And I can go through and look at it and say, yep, that's the data that I want. So I can go through and I can copy that test file back to the directory that I want and make use of it there. Now, this directory here, because I am in a snapshot directory, if I try to touch a file, it's going to not allow me to do because it's a read-only state. But I can recover individual files there. Likewise, from Windows, I have a document here for this. If I go through and I look at my document, let's say I've got some data here. It's got a few different timestamps with it. Let's say I make a change with it. Here, I'm going to save this file out, and I realize after I save it that, oh, gee, maybe I didn't want to do that. I want to get that previous version back that I had. So I can just come in here, I can right-click on it, go into Properties, and we will see from this under previous versions that I have previous versions of this file. Now there's two different previous versions here from different dates here. So this file here there's two different versions out there, one from 853, one from 802. If I'm not sure which one I want, I can go through and I can say, hey, I want to open this one. And it says, okay, that's this file here. Okay, maybe that's the one that I want. I can look at the other one. I can say, open that one. This shows me a different version of that file from that time. But again, this is just the timestamp as to when that file was changed at that point. For it, it doesn't necessarily line up with the snapshots. It just shows because a lot of those snapshots are just of the same file. So I can go through and restore either one of these files here. For this, let's say I'm going to grab the most recent change here, say restore, and it says I want to go through and I want to restore this to the live file on this, and I can look at this live file now and see, yep, it's back to what I had there, and I can proceed from that. So very easy to go through and utilize. Likewise, for global snapshot clones, I can go through and I can make a clone for these. So if I go back into my VMS GUI here for this off of one of these snapshots or go to my global snapshot clones, I can create a clone from this snapshot to make it read write. So I can say pwags test one, default tenant here. And we're going to say this is going to be the local one here. It's going to be the local default here. It's going to be the source path for this. pwags NFS for this. It's going to give me my list of snapshots. I can select whichever snapshot I wish to go through and use, and it will create that there. Now, it will create that snapshot locally. It'll create that path locally. I would then need to go through and create a view based on that path, which I could then go through and export out. So this will take a second to go through and create it, but that's kind of the general flow of things. So with that, that concludes the webinar for the day. Kristen, do we have any questions?
We do. We had a lot of questions come through, and there are two actually that we wanted to share with you. So I'm going to see, those are going to pop up on the screen. Here we go. So pull and push based replication is the first.
Yeah, so the replication is whether it's pull or push really is kind of a misnomer. I mean, the schedule is determined by the source system, whoever is the source, and it will go through and replicate based on the schedule that it has. The replication policies, the protection policies that you have defined are copied between the two different clusters. They're aware of what's there, but ultimately it is going to be the push. It's going to be the push from the source to the destination. And we can have two clusters replicating between each other, different paths in different directions, for that.
Awesome. Okay, and then we've got a second question as well about test failovers.
Mm-hmm. Yeah. So for a test failover here, if you want to make sure everything is working fine there, again, this could be your options would be if you wanted to go through and do set up your replication job from there. You can do a ungraceful failover where again it would go through and put the destination into a standalone state. And when we modify the replication and put the destination in a standalone state, that stops the replication from going through and continuing on. So it makes the destination read write. It allows you to make modifications to the destination for that. It doesn't change the source. There's no risk to the source in doing that. The other thing that you can also go through and do is that when data is on the destination or when the replication is on the destination, that data is available read only. So you can go through and you can establish your views on the destination side, establish your VIP pools, and present that data out in a read-only format while the replication is going on. If you want to go through and make that read-write, sure, you can go through and do that again, either by doing the standalone setup for the replication or by creating some snapshot clones based on particular snapshots to do your testing for that. So a couple different options there that you can go through and utilize.
Awesome. Well, thank you for answering those questions. Thank you to all of you for jumping in and asking questions, for joining throughout this session. It's been great to have you on. I've put some links in the chat, but we do send out an email with the recording afterwards. And it's also posted inside our customer learning portal and on our VAST YouTube channel. So look forward to that. And we will be sending out an email before too long with information about our next customer training webinar. We do these every month to help you as VAST admins stay informed. So with that, we're going to conclude today's webinar. Thank you so much for joining us.
Thanks, folks. It's been a pleasure. Have a good day.